Has anyone had any issues with setting it up? Hopefully it's a relatively simple two-step process. If there's any issues, feel free to raise your hands. If not, I will just continue. Okay? So yeah, so today, basically, I will be trying to talk about these main things. I'll try to introduce what CI/CD is, what exactly is GitHub Actions in the whole space of CI/CD. We also look at the anatomy of a GitHub action, and spend a bit of time on the hands-on activity, which is basically building out your own CI/CD pipeline from scratch using GitHub Actions. So hopefully you guys can get to see using CI/CD live and maybe translate it to your own projects. I'm not sure if we have enough time, if we will have enough time for the very last section, but there are several kind of advanced use cases you can have with GitHub Actions. And so I'll also try to cover those. But if I don't have enough time, the wiki has very comprehensive amounts of details to hopefully introduce it, and you guys can follow along. All right, cool. So let's go. Why did it go down? So let's go. All right. So I'll just use the wiki for the rest of today because I think it's a bit easier for me. Because I didn't have time to prepare all the slides. But basically, I'll just do a quick introduction of what CI/CD is and also what GitHub Actions is. Right. So CI/CD in this case, according to Red Hat, basically defines two different terms. You have CI, which is continuous integration, and you have CD, which is continuous delivery and or deployment. CI basically just means that you want to be able to kind of automatically integrate any code changes into your existing repository. So for example, if I'm making a pull request, I want CI to run unit test automatically. I want it to run linting automatically. So those are what CI represents. CD, on the other hand, I think quite self-explanatory. It's basically a automatic deployment where you can push, for example, to main, and it automatically pushes it into production, right? So that's kind of a pipeline that you're trying to build where you use CI to kind of validate and test your code, but you use CD to then deploy into production. So you're kind of building this local to production kind of pipeline at the end of the day. And the key thing to note here is that there isn't really a specific one-size-fits-all pipeline you can use for every project. So if I'm using Node.js, it's different. If I'm using Python, it's different. If I'm using Java, it's different. So everything is different. So that's the reason why we are here today, to really build out this kind of fundamental understanding of what CI/CD is, and also what GitHub Actions, which is a tool you can use, really does so that you can actually effectively use it. All right, so GitHub Actions is not the only one. You have things like Travis CI, Circle CI, and Jenkins, but in this case, we don't really care about the first three. We only really care about the last one, so we'll only talk about the last one. So yeah, so the bottom section is just what is GitHub Actions. So GitHub Actions was introduced in 2018. Basically, it's GitHub's version of its own CI/CD tooling, where it is very, very deeply integrated with GitHub. So this means that you can hook it up to actions with GitHub. You can hook it up to events that happen in GitHub. You can hook it up to issues, to pull requests, to labels, all sorts of different things, because it is built directly with GitHub itself. So GitHub Actions is basically the tool in which we will try to create all of these CI/CD pipelines that I'll be talking about today. All right, cool. So is anyone lost? Hopefully not. It should be a light introduction at the moment. So yeah, so if there's any questions, feel free to stop me at any time. Yeah, so the next thing I want to kind of talk about, which I've mentioned in the contents, is the anatomy of a GitHub action. So there's a lot of text here because the wiki is designed for you to like sit down and read at your own time and spend the time to actually digest it. So I will just be talking through parts of the content, and hopefully you can also see where all of this is. So yes. So basically, GitHub Actions revolves around this idea of a workflow, right? So the workflow is really the central piece of all GitHub Actions. And within a workflow itself, what you would have is you can have multiple events that can trigger a workflow. This means that, for example, if I need a pull request to cause a workflow to happen, the pull request can be the event. I can also have it be a push to a branch, or I can have it be when an issue is created. So it's all sorts of different events can trigger a singular workflow. And you can have multiple workflows that can kind of scale as you go, right? The next kind of piece of information that we need to know about GitHub Actions is the concept of jobs. So you can kind of see here that we have two jobs, or two sets of jobs that run in parallel, right? You have the first set of jobs, which is kind of a dependency set of jobs, which is job A, then job C, then job D. And you also have an individual job, which is job B. And by default, in GitHub Actions, what you would have is you would have each job running in parallel. But as you can see with job A, C, and D, we can kind of also create some kind of dependency graph, where if you perform like topological sort on it, you actually see that it becomes like a proper like topological order, where you need A to complete before C and C to complete before D. So yeah, so you can either create jobs that are sequential or you can create jobs that run in parallel. The next thing that we're interested in is to notice that each job actually has a runner. So what runners are basically just virtual machines or virtual environments that you can think of that execute the details of the job, right? So this means that each job can run in its own operating system. So in this case, job A, C, and D run in Ubuntu, and job B runs in Windows, right? And so the power of this is that I can have certain jobs that need to be running in Windows, but I can also have certain jobs that need to be running in Linux, and I can have both happen together in the same workflow because they can run in parallel, right? The last part, and a good thing to think about each job is that they run in their own effective like kind of machine. So they have their own file systems, they have their own memory, they have their own like dependencies you install on them. But what job A sees or what job A has is not what job C has. And so just because job C depends on job A doesn't mean that C can see whatever happens in A. It just knows that A is finished, so it can start running. And we'll kind of talk about how we can leverage this kind of behavior to actually string jobs together and share data between our jobs. The last thing is that each job actually contains different steps. So a step basically just runs within the operating system itself, and all it does is it runs a bunch of commands that sets up the virtual machine that we are running, and allows you to run some kind of behavior at the end of the day. Okay? So hopefully, is anyone clear, or is everyone clear with this? Is there any questions with what exactly goes into a GitHub Actions? We will kind of talk about each individual piece later on. Just want to give a quick highlight overview of this. No issues? All right, cool. So the example application, I kid you not, literally does not matter. You don't actually need to know how to read the code because the whole purpose of it is just to write some actions on it. But I'll just explain what it is. It's basically just a very simple calculator app. I was very tired when I wrote it, so forgive me. But basically, it just lets you add, subtract, divide, and multiply. That's it. And the key goal of it today, which I will actually talk about later, is that we actually want to implement this type of workflow that you will very typically see in most projects you will actually write, right? So a very typical workflow you might see is you create a fork, you work on some feature on the fork, you try to make a pull request onto the fork itself, onto the original repository. And what happens when you run when you do a pull request to the repository is that you actually notice that some set of GitHub actions will run, right? You actually see like some things will fail, some things will succeed, and that's fundamentally what we are trying to replicate today. So we can basically break down whatever I've just said into two key tasks we want to achieve. The first one is to run our unit test. So in the example application I gave you guys, there is a unit test file that effectively just behaves like a regular unit test, and it fails when there are certain conditions that are not met. The next thing we want to do is to perform linting. So you want to make sure that there is no coding convention violations or there is no formatting issues. So that's what we want to perform after. And the very last step is, it's not very fun if you only see errors. You also want to see it live. So we'll also try to build a workflow that actually lets you deploy automatically to GitHub pages. So hopefully this is similar to what you might be doing in your own applications and translatable. Okay, so yeah. So hopefully all of you have the sample repository set up already, or the example app. If you guys don't, the wiki has the instructions. You go to basics of GitHub Actions, and you just scroll all the way to the bottom, you'll see setup. Or I guess second last section, you'll see setup. So set it up accordingly. I will do the setup right now so that it's easier to follow along. But yeah, cool. So I'll take a seat because I need to type. But basically, for part of the setup, what you want to do is you want to go to this repository. You want to basically, oh my God, so many people created forks already. You want to create a fork. So I'll do this along with everyone so that it's easier. So I will create a fork. I will just create it to like our NUS Hackers one because, yeah, I didn't prepare another org for this. But basically, Once you've created the fork already, give it a while, and then you can clone it. So to clone it, I think most people should have cloned it already. If not, you can just go to the repository, click this, go to your terminal. I have a folder for it, so you can just run git clone, and you should see this repository. Okay, so if I just do ls, you'll see CI/CD calculator, and I go into the directory. Okay, cool. So I will just open this in VS Code, because I think the last time I used like NeoVim for demonstration, like it was quite confusing. So for the sake of everyone, I'll just use VS Code. But yeah, so as I've said, the whole repository probably does not actually matter. You don't actually need to know what the code does. What's important is basically this file, which is calculator.test.ts. It's a very simple unit test. And it's just powered using this utility class. Okay, so it's super simple. Hopefully it's not confusing to anyone. You don't actually have to think too hard about what the code does. Yeah, so the next thing that we want to do, or I guess the first thing we want to achieve, is to actually start running our unit test. So if you look at the page, there's like a lot of content. And that's because, again, I said this wiki is for you to read on your own time. So it contains all of the information I'll be talking about. But since I'm talking about it today, right now, I'll just explain each part so you don't really have to think too hard about what you're reading. Just use it to go back if you're confused at any step. Okay, so for all 3 steps of today's demo, we will be talking about kind of 5 main questions when we deal with GitHub Actions, right? The first thing is we have to think about how do we construct our workflow. So we've mentioned that the workflow is the centerpiece of all GitHub Actions, so we want to figure out how do we construct it. The next thing we want to do is to figure out how do we design the actual workflow, what is the code necessary for it. Afterwards, I'll explain individually what some of the lines mean, what they behave, how they behave and what they do. And then after that, I have some visuals to help you visualize what exactly was done during the workflow itself. And the final one is that we can actually try to verify that the workflow works. Okay, so there's a lot of text here. Again, don't worry too much about it. I'll be talking through it. So basically, when we construct our workflow, we basically kind of answer 2 main questions at the start, right? So we have no workflows existing. We want to just construct something new. What we will think of is 2 questions. We'll think of, firstly, when will this workflow run, right? So this is fundamentally asking the question, what events will trigger the workflow? So if you think back to the diagram I showed earlier, these are the events that feed into the workflow itself. The next question we're going to ask ourselves is, what will the workflow do, right? Because depending on what you want to achieve, if I want to run a unit test, if I want to, I don't know, do some weird polling behavior, this is the question we have to ask, right? And so you can kind of break down this, what will it do, into more questions. But fundamentally, we can kind of talk about these, or for this particular instance, we can talk about them as the operating system doesn't really matter because the unit test is not specific to an operating system. The next question is like, what programming language is this in? It's JavaScript. So we're using Node.js basically. And the third step is that what steps should be running to achieve the expected workflow, right? And so in this case, because our goal here is to run the unit tests, we will want to actually be able to execute the unit test. So maybe just for demonstration purposes, let me actually run the So let me actually run the thing. So if you're running it locally and you're very curious what it does, you can actually do yarn to install all your dependencies, and you can do something called yarn test. This should fail, expected, because I put a bug in there on purpose. It's not because I'm bad at programming, but basically what you will see is that the unit test will run, 3 of them will pass, 1 of them will fail. Expected behavior because it is supposed to be 0.5, not 0.4. But basically, this is the behavior we want to see on our workflow, right? We want every single person who pushes a pull request to our repository to see this, see this set of errors here. We want them to see these errors. We want them to not be able to make a pull request or not be able to merge it, right? We want to make sure that these are in place. And so how do we achieve this, right? So I kind of talked about how we construct it. Now we'll look at actually writing out the CI/CD. So for the sake of following along, because I've realized that it's sometimes a bit hard to like follow one line by line because it's easy to mix up what lines are needed. I've provided the entire workflow file for now. So copy this and create a subfolder in your repository. So if you're using VS Code like I am, what you can do is you can just right click. Oops. You can do this. You can create. Hold on. Yeah, you can create a folder called .github, sorry. You create another folder called workflows, right? So you have .github/workflows. And then inside of this folder, you add a file and we will call it ci.yml. So GitHub Actions is a YAML-based specification, which means that you use the YAML language. YAML just means yet another markup language, I think. So basically, it's just a way to declare your workflow. So if I create the file ci.yaml, it's empty, of course, and just take whatever contents I included and paste it, right? So for now, don't think about it too hard. Don't think about what exactly it does. I'll explain it in a bit, but just paste it, and you can save it, right? So you should see this file, and I'll slowly go through each individual line, so hopefully everyone can understand what exactly you have just done. Okay, cool. So now I'll basically do the laborious job of explaining every single line of a piece of code. The first thing we do is we actually define something called the name of the workflow. So the name of the workflow is not really necessary, but we do it because it's easier to recognize, and generally just better etiquette if we want to have like multiple workflows, right? So the first thing we do is to declare the workflow name. And so we specify it using the name key and put the value afterwards. The next thing we do is we specify the workflow triggers. So if you go back to your file, you actually see that after the name line, you actually see something called on, and it specifies pull request and workflow dispatch. So as we said earlier, this workflow has to run when someone makes a pull request. So GitHub Actions does something really simple. It literally just gives you the name pull request, right? The other thing that I've added is something called workflow dispatch. Basically, what it lets you do is it lets you manually trigger your GitHub Actions when you're on GitHub. I'll be demonstrating this in a bit, but essentially what we are trying to do is we want to say that you're able to run this both when a PR is made, but also manually, so you can verify it without having to like actually create a PR yourself. Okay, so this is basically satisfying the first half of like the first section of our diagram earlier, which is we specified the events that will trigger our workflow itself. Okay, the next set of things we want to do is we need to start defining the jobs. So recall earlier that I said that jobs are effectively just virtual machines that run your behavior. And so in this case, I need to specify which jobs are available to run, right? And so in this case, I'm specifying it under jobs and with the unit test key, or it's basically the ID of the job. So the ID basically lets us refer to the job itself, okay? The next thing we want to do is we specify something called runs on. And so this is what I've mentioned earlier, which is that each job has a runner, and the runner basically has its own operating system. So in this case, my job just runs on Ubuntu. As I've said, you can change this to Windows if you really want to. I wouldn't suggest it because I don't think I can debug it for you if you change it to Windows now. But so stick to Ubuntu for this demonstration, but you can play around with it in your own time. And yeah, so basically what we have done so far, if you go back to the code, is we've literally just only looked at these first few lines, right? We have defined the name for our workflow. We have specified which events will trigger the workflow. And we have created one singular job called unit test. And all it does is we specify that it runs using Ubuntu. That's it, okay? So hopefully this is clear for everyone. If it's not clear, please raise your hand or stop me. If not, I'll assume everyone's okay. Yeah, so an important thing to note, given the fact that we specify the current operating system of our runner to be Ubuntu, is that we actually have access to all of Ubuntu's, well, most of Ubuntu's command line. So this means that I have access to Bash as the default shell. I also have access to the apt package manager. And I can kind of leverage those when I'm building my own jobs and workflows to actually use these behaviors accordingly, right? So yeah, so just think of it as you're literally running it on your own computer. I am quite literally maybe running it in my terminal, for example, and I want to achieve whatever I've done in the terminal in GitHub Actions as well. Cool. The next thing we want to do is to actually start declaring steps, right? So just recall the other part of our anatomy is that each job consists of a set of steps, right? This set of steps run sequentially, and effectively what they do is they kind of prepare your virtual machine to be able to actually execute some kind of behavior, execute your end result. In our case, it's an end result of running some unit tests. Okay, so the first thing we have to do is you actually realize, or if you start debugging and you start playing around with GitHub Actions, you actually realize that by default, our jobs are empty, right? So we have created this completely open virtual machine. It has Ubuntu installed on it, but it basically has an empty folder, right? There is nothing inside of it because I have not installed anything, expected behavior. So what we want to do is to actually fetch the current repository when we do a pull request, right? So when we do a pull request, what we want to do is we want to fetch the person who makes the pull request. We want to fetch that repository, and we want to be able to fetch the data that is inside. So effectively, what we are doing is each step comprises of two different types of things, right? You can either use an action. So an action is kind of this pre-built reusable workflow that you can keep reusing, or you can actually run a set of steps or a script that you want that actually just executes within the virtual machine itself. Okay, so basically here, it's a lot of text. Sorry once again, but basically the point of this is that all we do is we use an action. So it uses the keyword of users. And the action is basically the action checkout action. And what it does is it, by default, fetches the latest commit of the current repository, and it performs effectively a clone onto the virtual machine. So after this step, actually maybe I should have brought the diagram earlier, but basically after this step, if you can see here, it's a very handy diagram, I think. But we have our initial state, which is our Ubuntu runner has nothing inside. It's an empty file or empty folder. And by default, what GitHub Actions does is it declares this environment variable called GitHub Workspace. And so this is basically the folder you start with. This is the root directory, right? You don't actually need to know where this root directory points to. It doesn't really matter. All you have to think about is what are you performing in this root directory itself. So after step one, which is fetching the repository, you actually see that now my runner goes from having a completely empty workspace to having all of the files that belong into your pull request. And that's basically what fetching does. It clones the latest commit onto your workspace by default, and it leaves all of the files there, right? It's pretty handy because now I can basically start treating this as a repository, right? I can treat this as a file system. Cool. So going back up, yeah. So basically that's fetching our repository. The next thing we want to do, again, so remember that I've said all we have is an Ubuntu machine. It has access to things like Bash. It has access to now our repository. But you can kind of intuitively realize that it might not have the dependencies you need to actually run the repository, like run our project, right? Because we have it in JavaScript. We need it to execute the JavaScript files. So in this case, we need to actually install Node.js. So to install Node.js, again, we use a different action. This time around, it's called the setup node action. And you actually notice now we actually start to pass new parameters. We have width and two different parameters. We have node version and cache. So node version is literally the version of node that you plan to install. So if I just do it on my local machine, what you will see here is if I do node version, it's 23, right? I can change it to 23 if I want to, but in this case, I'm going to stick to 20. So that's what node version does here. The next thing that we have is cache. So cache is basically which package manager you want to use, right? In this case, because I used Yarn when I created the project, so we are going to use Yarn, right? Otherwise, you just have two different log files. Not really a problem, but better to just stick with whatever the project uses, right? So in this case, I'll specify cache to be Yarn. Okay, so now if we go back to our diagram, you actually notice that once we have gotten to kind of step two, right? We have gone from having a runner that has our files available to now having a runner that has our files available and also having Node.js 20 as our dependency, right? So now we have access to Node.js 20 within our runner, within our job. Okay? Is anyone confused? Just curious. Okay, cool. We are finishing this workflow very soon. Don't worry. The next thing we have, or the second last step we need to do, is we need to install our dependency. So if anyone has dealt with JavaScript before, I know I said you don't need it, like knowledge about it, but if you have dealt with JavaScript before, you know that you have to install your project dependencies. And so we want to do it in our virtual machine as well. So we'll use Yarn in this case, right? So you'll notice here that we're no longer using users, we're actually using this keyword run. And essentially what it does is it lets us run a script or a list of, or a set of commands basically within the virtual machine itself. So as I've said, we have installed Node and we have also access to Ubuntu. And so in this case, we have both Bash and whatever dependencies we might have, like yarn and npm and Node, sorry. And so in this case here, what we are doing is we're effectively just installing all of our dependencies, right? You don't really need to think too hard about what it does underneath the hood, because this is not CI/CD for yarn, but basically it just pulls out React, it pulls out the testing framework, all you need. Okay. The last step, which is finally, we can get to start running our unit test. So we declare a very last step, which is basically to run. So it executes another script. It runs the command. So the front part of this just means that I'm setting the node environment, just to be clear. You can remove it, it doesn't really matter, but I just put it there because it's normally what I've done. So force of habit, sorry. And you can just run yarn test, which is basically what I've done earlier, right? If you look at the repository I had earlier, when I ran yarn test, it failed, right? This is exactly what we want, and this is why we are running it in our action as well. So I've kind of just explained this entire file. Seems simple, but there are different kind of steps and processes to writing all of these. And intuitively, hopefully, as I've explained all of these, it lets you build out these two kind of visualizations in your head, right? Why can't I open this picture? Okay, whatever. So the first visualization you would have is what exactly my workflow looks like, right? In this scenario, as I've said, we have two different events. We have the pull request event and we have the workflow dispatch event. So two different events. They both trigger this file called CI. So that's my workflow itself. And within CI, there is only a single job that runs on Ubuntu. And it first fetches the repository, sets up Node.js, installs my dependencies, and runs the unit test. Okay? So that's literally, we have spent this entire time explaining this. But hopefully, the process of explaining it helps you understand exactly where all of the pieces fall into. And so when you actually look at the overall state of your job and of your runner, you actually realize that after all of these steps, you actually reach the final step where, sorry, so step 3 is when you actually did yarn. So yarn just adds the node module folder. And you would basically have the final folder structure of our system here, right? You would have it in Ubuntu, you would have it have your current project folder, you would have node modules because you ran yarn, and you would also have the Node.js dependency. Okay, basically that's all we have done. And so I've talked a lot, and so let's actually see this happen and work in real life, right? So the first thing I'll actually demonstrate is manually running the workflow, because I think that there will be quite a bit of problems if we all try to do pull requests, mainly because I foresee that my instructions might not have been clear. But basically, we'll manually run the workflow, and then there is an exercise at the bottom to actually run a pull request. I'll leave it to you guys to try it at your own time. So to actually run the workflow, what you want to do is you want to basically, so this is Git like instructions. I don't know how many of you are super familiar with Git or not familiar with Git, but I guess I was assuming some familiarity. So what we're doing is we're just adding the file, the CI file we just created. We are committing it and we're pushing it to our fork, right? So this should all work on your forks, not on my repository. Mine is an individual fork, okay? So basically, what we want to do is we want to do a git add for workflows ci.yaml, right? After you've added it already, we want to run git commit. We want to specify the value of add ci, right? It doesn't really matter what message you specify. This is just for the sake of demonstration. And then after that, you want to push it, right? So this should now push to your own fork. So you shouldn't follow the URL that I included. It's my fork. So if you have your own fork, follow that. But basically now, if you go back to your fork here, which I have mine here open. Sorry, wrong one. Yes, this one. So you will see now, if you refresh the page, nothing changed, which is basically what is expected. To see the workflow you just created, what you need to do is you click into Actions. And now on the left side of your screen, you should see CI/CD pipeline, which is the name that we gave earlier, right? So if you click into it, you'll see now there is still nothing, but we have this nice little banner here. It says that the workflow has workflow dispatch trigger, and you can run the workflow. So this is exactly why I gave the additional event. This is just so we can demonstrate it this way. So now, if I select run workflow and click run here, nothing happens. So I don't know why GitHub doesn't do this, but it doesn't refresh or like update the thing for you. But if you just refresh the page, you actually see some new UI pop up, and it's a new entry. And this is the workflow that is running as if a pull request had triggered it, or as if a workflow dispatch had triggered it, which is the latter in this case. And so those who are curious will actually start clicking into it, and you realize that you're greeted with this funny little page. You don't actually see much information, but if you let it run for a little while more, you actually see that the unit test will fail, right? Again, this is expected. On my computer, it fails because it's intentionally placed there. But what's more interesting in this case is if you look at how we describe it, it literally says drops here, which is unit test, which is what we defined earlier. And if I click into unit test, what you will see is that GitHub actually provides a lot of details about the steps, right? It tells you literally the step we use to fetch our repository. It tells you the step we use to set up our Node.js dependency. It even tells us that we ran install dependencies, and it told us the logs of the command, right? And more importantly, what we see here is that it tells me the same exact message that I saw when I ran it on my computer, right? It's basically 1 divided by 2 is 0.5, not 0.4, right? So hopefully you guys can see that the workflow has basically been successful, right? We've been able to effectively go from having no automation to running our UI, running our test, to actually having some automated way of actually verifying that the unit tests continue to work on my repository. Yeah. Actually, maybe I have time for the pull request. Okay, so I'll go through the pull request as well so that we can actually show off what pull request looks like. But yeah, so basically I've talked about all of these. So for the sake of demonstration today, I will also show how you can actually trigger this workflow using a pull request. So we actually create a pull request. Yeah, sorry. So up until this point, is anyone confused, or anyone not sure what exactly has just happened? Any raise of hands? No? Okay, perfect. Basically now what we want to do is we want to just demonstrate having a pull request event and trigger the workflow. So we basically want to validate that this actually does run with a pull request. Based on logic and based on reading the documentation, you would know that it runs, but let's just be extra sure. So what we want to do is we want to basically fix the bug that we introduced in a separate branch, create a pull request of that fix to your own fork, not my repository, your own fork. And then after that, you will be able to see the CI pass and fail. Okay? So because, as I've said, this is not a programming exercise, I'm not going to make you guys try to figure out the bug. The bug is basically because I put 0.4 instead of 0.5 here, right? So what you can do here is there's a list of steps here, but I'll just go through it right now. In your terminal, right? I'm just running my terminal in VS Code. What you can do is you can do git checkout -b. Basically, that creates a new branch. And let's just say this is fixed unit test, right? So you guys should all be in a new branch now. The next thing you want to do, that I've explained here, is we want to fix this unit test. So I've even given you guys the line number. So just go to the same file, which is calculator.test.ts here. Go to line 13. Oh, I don't have line numbers turned on. You know what? Never mind. I will assume you guys have line numbers, but line 13 is this line, basically. And you can just replace the 4 with a 5. Okay? Once you guys have done that, just save the file. Then the next thing you want to do is you just want to save this change. So I'll just do git add calculator.test.ts. And I'll commit this file. So fix unit test. Okay? And then afterwards, I'm going to push. And in this case, you change the parameter, the main, to fix unit test, which is the branch name. Okay? So just push it. Shouldn't be anything too flashy. You'll see some message here. You don't really have to follow it. You can just follow what I'm doing. So if you go back to the repository, so this is your fork, not mine, your fork, and you click code, you should realize that there is now this message at the top. It says fix unit test pushed, has been pushed, right? So everyone just click on compare and pull request. Okay, so this is the part where if you do it wrongly, you'll send me emails. You're supposed to send yourself emails, so it's not me. So in this top section, click onto the base repository. Oh my God, there's so many people. But basically, type your own fork's name. So if your name is, I don't know, if your name is AppDevin, then type AppDevin and select that particular fork, that repository. In my case, mine is NUS Hackers, so select it. So once you have done that, you should see that now the selector disappears. Okay, so this means that I'm creating a pull request on my own fork, right? So you guys should do the same thing, because otherwise I'll get the emails that you guys should be getting, not me. Okay. So if anyone has any problems, try to raise your hand and maybe we will walk around and see if anyone can help you. But basically, once you have this already, what you want to do is just leave everything blank and click create pull request. Okay, so hopefully, if you guys had all done this correctly, you should see no conflicts. And if you wait a bit more, it should change, right? So this is what GitHub Actions look like when you're using GitHub itself. Essentially, what you have is it tells you what is the actions that have run because of the pull request. And so in this case, it tells me the name, which is CI/CD pipeline, and it tells me the job afterwards, which is unit test. And it even tells me what triggered the event, pull request. So if you click onto it, you'll go back to the same page we saw earlier. And now you'll see that the fix unit test command, if you expand it, it succeeds. And that's because the command, we've really basically fixed the unit test, right? So this is hopefully proof that we have not just written a workflow that we can manually trigger, but also proof that the same workflow can be triggered using a pull request itself. Okay? Has anyone had any issues up to this point? I think this is probably the hardest part of this. So like just to be safe, has anyone had any issues following along thus far? No? Yeah, I'm hearing a bit of like chatter. So is there any issues over there? Sorry? You can't commit to the file. It's workflows. Okay, so maybe you will encounter an issue where the file doesn't actually exist or like the workflow can't be found. The name of the folder you should have is GitHub Workflows with an S. The S matters. I don't know why, but the S actually matters. So like add the S at the end and hopefully it works and commit the file again. Okay, wait, I guess another point of clarification, there is a dot in front of GitHub. The dot also matters. So the dot and the S at the end both matters. GitHub is very particular about the naming, so make sure it's .github/workflows. Yes. Can I maybe get a show of hands if anyone has not been able to run the two things we have just done, the manual pull request, the manual trigger, and the pull request? Is everyone able to follow? No issues if you cannot follow. I'll just want to make sure that most of us can follow along. I guess another point of clarification is that this should be the root of your project, and .github/workflows belongs under the root of it. So under the root, you should also see README. And you should also see source. If you have it underneath source, you're wrong. You only need to have it underneath the root. Okay? So just be clear. The GitHub has dot in front, S at the end, and it should be under the root. Anything else will not work. I know it's very confusing because it has some weird arbitrary rules, but it's the rules we follow. So I guess we resign our fate to this. Yes. Yes. So I guess as some of you guys are still figuring out the what we have just discussed, I will just quickly answer one of the questions, which is where do the events come from? So I've included a link here. Maybe it should be more obvious, but there is an official documentation for all of the events that can trigger a workflow. So you can see here that you can trigger a workflow by forking something. You can do it by doing something called Golem. I don't know what it does. Don't ask me. I just know it Golem exists. You can also do things like having it trigger when a pull request happens, when someone watches the repository, or when someone calls the dispatch of the workflow. So this is where we find all of the events that can happen. And it just so happens that I was interested in pull request and workflow dispatch. So I picked from this list. Okay? Sounds good? All right. Okay. So has anyone still have any issues with this very first example? Oh, yes. What happened? Okay, wait, I think Peter pointed out that if you have, wait, guys, if you guys are having problems with pushing or committing the workflow, you can actually go to actions on your fork, click on new workflow, and oh shit, there's so many text. Give me a sec. If you go and click the skip this and set up your own workflow, you can actually paste the same file that I included earlier. So it does the same exact thing. It adds the file for you, and you can actually run and deploy it locally on GitHub. This won't let you do the pull request because like fundamentally it fails, but basically this is a shortcut if you want it. Okay, so what you do is just you go and copy and you paste. And basically you can just change the name of this file. So someone asked if the file name matters, the file name does not matter. I can name this I love, I don't know, cookies, and it will still work. So in this case, if you add this file, you can click on, you can click on commit change. And when you click on commit change, you would basically do the same thing as whatever I've done on my terminal. Same thing. So don't have to worry too much if you can't get it to work for now. Okay? All right. So this was the thing I said about being sure that you didn't pull requests to my repository, which is if you go and okay, I'm pretty sure I'll see money. Okay, yeah. So for whoever's name is here, you basically PR to the wrong repository. So you're supposed to PR to your own fork. So not my repository. So this was how I said, when you create your pull request, you need to specify your own name. So here, I specify my own name. So in this case, the account is Wu Jiahao. So I'll put Wu Jiahao. If your name is Bob, you put Bob and you select the option that says Bob. Don't select my name. If you select my name, you're gonna not be able to see the workflow run. Okay, so that's probably the issue some of you might have. Okay, yeah, sorry, break time. Okay, wait. I think we've had a bit of a break, hopefully. So I will, no worries. I will continue on. There is basically like 2 more things we will have to do to like have our workflow. So if anyone is still stuck with like the first part, I think maybe you can, no worries. Maybe you can raise your hand and hopefully like one of the other core team can help walk around and help you guys. But if not, I'll just continue on to the next part. So yeah. Okay, okay, never mind. That's moment. So now the next step we want to do in this case is we want to start linting our code. So if you're not familiar with what linting is, basically all it does is it does some kind of checks, make sure that your code that you wrote doesn't violate some kind of coding conventions, is properly formatted, all those things. So that's linting. In this case, a lot of the times in our workflows, we also want it to be able to run linting when we make a pull request. So we want to make sure that A, the behavior of the code hasn't broken anything, and B, the code that you wrote still abides by some kind of convention. So this is why we need linting. Okay. So again, the 5 different steps that I've mentioned earlier. The first step is constructing the workflow. So thinking of what we actually need to do. So again, the first 2 questions are quite straightforward to answer in this case. When will it run? Again, it's on the pull request. And also additionally, workflow dispatch for us to test. And what will it do? Basically, we just want to run yarn-lint. Okay, so yarn-lint is effectively the command that you would run on your local machine as well. You'll run this. It should have no problems because I write good code. But but basically, but basically, if you run yarn-lint and you have some problem with your code, it will flag it out to you. So we want this to check to happen when we perform a pull request as well. Okay. Another question that you can start asking yourselves now that you have an initial workflow is the question of whether or not this new thing you want to involve belongs in a separate workflow, whether it belongs as a separate job, or whether or not you can do it as the same job that we created earlier, right? So there's a bunch of like pros and cons to doing everything. In this case, I'll choose to do it as a separate job because I want to demonstrate parallel jobs. But basically, in this case, in some scenarios, you might add it to the existing workflow, which is what we're doing. You might add it to the existing job. But you can also split it out. Okay? Is anyone clear with what we want to achieve right now? Wait, is anyone not clear what they want to achieve now? Everyone clear? Okay. So the file looks a bit longer now. It's just because I added a new section. But same thing as just now. If you run copy, right? Actually, in this case, maybe for the sake of simplicity, because I'm afraid that someone does the commits and pushes again and it fails. So for the sake of simplicity, I will do it the UI manner. Okay, so I will copy this, right? I will go to GitHub. So go to the repository here. Wrong repository. So you go back to your fork, right? You go to Actions. You click on New Workflow. And you click on Set up a workflow yourself. This one here. Okay? In this case here, you'll paste it. It's supposed to go into the same file as you had earlier, but because to demonstrate the UI part of this, we'll create a second workflow. But if you think about it, I can basically add the job to the same workflow we created earlier. Same thing. But for the sake of demonstration, let's just do it as a separate file now. Okay. So now I will change the file name. Let's just call it CI2. Again, file name literally doesn't matter. So I'll just call it CI2 in this case. You can click on commit. And you just click on create. Just commit the changes. And now you should see 2 files. First file, ci.yaml, is whatever you guys should have created earlier. Second file here is ci2.yaml. This is the one we just created. Okay. So hopefully now that we're using the UI, it's easier to follow along, and easier to demonstrate. Okay. So if you open up the file, you just see this. Has anyone had any issues with doing this? Any issues here? No? Okay, nice. So basically, you will notice that the steps that we included in the linting. Okay, so I guess I'll explain this. You can see at the bottom here, we have unit test. It's the same job we had earlier. You will see above this is something called linting. It's a new job. This is what we want to run. Or this is a new thing we're adding. And the other thing you'll notice is that there is actually basically the same 3 commands, right? The first thing you want to do is fetch the repository. Then you would set up Node.js. And then after that, you install the dependencies. It doesn't change, right? It's the exact same thing. What is different though this time is that we add a new instruction called yarn-lint. And this runs the script, same as yarn unit test, the yarn test. And all it does is it calls the linting that we included in the project. Okay? So basically, it's whatever I've just said here. Very simple. We're just modifying one singular step. So now that we have done this, you actually notice that in theory, if I had done it to the same file, I would have a workflow that looks something like this, right? I would have the same 2 triggers or same 2 events, the pull request event and the workflow dispatch event. and you would have the same unit test event on top, but you also have now a job that runs in parallel, which is called linting, right? So this is the new thing that we have chosen to add, okay? So this means that if I run the workflow, it should trigger both of these jobs to run at the same time, okay? So hopefully this is a lot simpler than the previous one because we have literally explained a lot of the previous things and we have replicated them here. We've just changed one command. And so again, we can verify it, but since we don't have to use the terminal, we can use the UI. Go back to your actions. And now you'll see there is two names. I did not name it properly, but if you click on the second one, I believe, yes, the second one should be correct. You should see now that it is empty because I've never ran it before. And now what you want to do is, again, manually dispatch this workflow, right? So just run the workflow and refresh your page. What you should see now is, again, the job is running one more time, or the workflow is running. And if you click into it, this time, you will see two different jobs that run. The first job is the one that we saw previously, which is unit test. The second one is linting, right? So unit test is relatively uninteresting. So I'll click onto linting. And you will see that now unit test fails because previously, as I said, the 0.4 to 0.5, I didn't add that change directly to main. But you'll notice that the other job, linting, actually passes. And that's kind of the beauty of using different jobs for different parts of your CI pipeline, where essentially what you want is for different jobs to not block the other. So in this case, if I had ran linting with unit testing, for example, that singular job might fail, and it might fail because of the linting, or it might fail because of the unit test. You would know if you click into it, but if you look at it from an initial glance, you might not find that out really quickly. Similarly, if you fail the linting but pass the unit testing, the GitHub Actions fails before it even runs the unit test, for example. And so the reason why we choose different jobs that run in parallel is because sometimes the output of one doesn't actually affect or doesn't actually matter to the other. So we just want to run multiple jobs at the same time and have different results. And that's useful for us, right? We want to know that a unit test fails, but a linting passes. So I only have to focus my efforts on fixing the unit test. Okay? So hopefully that is clear. And essentially, what we have done now is we have basically created, or let me go back to the target workflow. We've basically been able to replicate these first two tasks, right? We have created a pretty, well, I wouldn't say robust, but a pretty useful CI pipeline where you can actually run your unit tests automatically and lint it. Okay? So hopefully this second part wasn't as complicated as the first. It should be hopefully more digestible. All we are doing is just changing the command we use. Okay? So now I will go on to the very last part of the hands-on, which is deploying this application to GitHub pages. So before I move on, does anyone have any questions so far? Any issues? Yes, Jotam. Oh, because I wrote it. No, I'm kidding. So usually you might want to run integration tests. You might want to add more steps to the CI pipeline. So like you might need to make sure that the functionality between different classes or between two different utility methods work properly. So integration tests, or you might want to automatically fix the linting issues, not just raise the linting issues. So it's not a particularly robust pipeline because it doesn't do as much. But as I've explained, you can really kind of improve on it sequentially by adding new steps and adding different behaviors. So hopefully that explains the question. It's not because I wrote it, it's because in theory, it's not the best pipeline you can actually write for your code bases. Okay? Cool. So hopefully there is no questions. Or well, if you have questions, feel free to ask, but hopefully there's no problems with following so far. Now, I think it's a slightly more fun, slightly more interesting part, which is deploying to GitHub pages. So you'll be able to see the application running live on some domain, and hopefully that makes it a bit more exciting. So just to quickly give an example, GitHub Pages is a free static site hosting platform that GitHub has. So it's integrated pretty well with GitHub itself. Okay, so basically what we want to do is we want to go from having the code run locally to the code running on the browser by some server somewhere. So basically pushing it to production in this case, right? So in this case, we want it to happen when we merge it, or when we change main, or when we push something to main. Okay, so again, the five questions or 5 parts that we can answer. First part, we are looking at constructing the workflow. So now we can kind of think through the 3 questions we introduced, right? When will this new workflow run? So to be very clear, this is a new workflow that we want. And the reason why it's new is because it runs at a different time. So previously it runs when the pull request happens. But in this case, I only want it to run when there's a push to main. And so in this case, because there is a difference in the events that trigger it, the workflow has to be different. Okay, so hopefully that is clear to everyone why we are choosing to split it out, right? So that's the first decision. The second thing is that we want it to compile and build the React project. It's a lot of fluffy words. Hopefully, if you guys can understand it, it's great. If you guys don't understand it, completely fine. All we are effectively doing is we are going from having a project locally to having a bunch of files that are necessary to run my application on the web. Okay, that's it. That's all it means to compile and build this React project. The next step is to publish the generated build files to GitHub pages. Yes. Sorry, but I see both the linking code and the unit test .ci.yml. Is this first decision or just so I guess I need to be clearer, but for the linting thing, right, you're supposed to add this section only. So you're just supposed to add a new job. So it's the same file, but a new job. So that was hopefully to demonstrate having 2 different jobs. So it's the same file because you're editing the same file. I'm just adding a new section for a new job. Hopefully that's clear. Does that make sense? So basically, yes. So effectively, I'm going into the same file at the bottom, for example, and I just paste this, and that's it. Okay. Yes, correct. So the YAML file knows that there's 2 jobs that are running or that needs to run. Okay, so that's the design of YAML, and that's the reason why they chose YAML. Okay. Hopefully that was clear and makes sense. Cool. Okay. So now that I've clarified that, I will go back to this. Yeah, so the last question we have here is basically, is this going to be a separate workflow? Is it going to be a new job in the same workflow? Is it going to be within the same job? So as I've said in the very first question, we asked ourselves, this has to be in a different workflow. It clearly doesn't make sense to make it part of the existing CI pipeline, right? It's literally in the name deploying, so it's a continuous deployment. And so we want it to be a CD pipeline instead. So in this case, we have it as a separate workflow. Okay. And the other thing we can actually notice when we're actually describing the second question is that we effectively have 2 different tasks we want to achieve, right? The first task we have here is that we want to compile and build the React project. As I've said, basically just create the necessary files for GitHub pages to present it. And the second step or the second task we want to achieve is to publish this set of files to GitHub pages. How GitHub pages deals with it, not really important, because all we need to think of is we have some file that we can display, push it correctly to GitHub pages, and it will display it. Okay? So in this case, we have 2 different tasks, and we can kind of apply the third question again, which is, can we run this as a separate job, or can we run this as a sequential set of jobs? So the answer is you can actually run this in the same job, but for the sake of demonstration today, I will run them as separate jobs to show off one of the other features of GitHub Actions. So hopefully it is clear why exactly we're choosing to use it as 2 separate jobs, not 1 singular job. You can write this as a singular job. There is no issues. You just change a few lines and it's probably going to work correctly, right? Cool. So again, we've kind of constructed the GitHub workflow. And now we have a pretty long file, new file. Don't be too alarmed by this, hopefully. So what you want to do is you again copy the file, right? And as I've said, maybe it's easier for everyone if we just add the file directly through the UI. So we go back to Actions, click on New Workflow, set up a workflow yourself, and paste the contents. And you can rename the file again, doesn't really matter, but I'm choosing to rename the file to CD. Okay, cool. So you can commit the changes again. And you should see a new file, CD. And it should have the commands that you need. Okay? So hopefully this should be straightforward. And yeah, so now I will actually start breaking it down. So you will notice that there is actually a lot of different steps that are involved. So hopefully I can explain it in a way that's easy for you guys to understand, but if it's not easy to understand, let me know, because I will agree that this is probably not the most straightforward part of this. Okay? So we do the first thing, which is to set the conditional workflow trigger. So earlier we set our workflow trigger to be the pull request and workflow dispatch events. But in this case, as I've said with the first question we've answered, we want this to happen when we push. So in this case, we need to change the action to something called push, right? And when we specify push, we can also specify something called a condition, or well, it calls it the condition, but basically there are several conditions that we can run this particular workflow, right? So when a push happens, it looks at what branch has been pushed. And in this case, we are only interested when the push happens to the main branch, no other branches. So I can create a branch called ABCD, and if I push to that, it does not deploy. It only deploys with main. Okay, hopefully that's clear. The next thing is we have the build job. The build job is one of the two jobs that we have, and it is the first step that we want to do to compile and build the React project. And so in this case, the first 3 steps is basically the same as you have seen earlier, right? All you want to do is to fetch your repository, you want to set up Node, you want to install all of the dependencies, and then the new step we have here is actually building, right? So very similar to how we did the unit test and linting, we effectively call the build job that we include in the project, and this creates the necessary files to be published, right? So if you again scroll down all the way here and you click this, ignore every other diagram, and you look at step 4. Step 4 shows that a folder called dist is included. I think dist stands for distribution. But basically that is the output of a build step. That is what a build step generates. Okay, cool. So effectively, what these first 4 steps cover is it creates the necessary folders, or it has the necessary folders, the necessary dependencies, and files for React to deploy to GitHub pages. Okay, hopefully this is clear. This was the same as what we have done previously. The last step that is relatively newer is this step, where we actually call a different action, and the action is called upload pages artifact. And so this is the nice thing about having reusable workflows and actions, which is I don't have to write this logic myself. I can let someone else write it for me. So this is what someone else has written, and it effectively takes the distribution or the dist folder that we created earlier, and it creates what we call an artifact. So artifacts in GitHub are essentially ways to share data between your jobs or to store some kind of information about the run. So for example, if I want to run some code coverage, I can store the reports as an artifact, right? So there are a bit of restrictions with using artifacts, but essentially in our case, we want to be able to take the output, which is this distribution folder, from the job, from the build job, and pass it over to the next job, which is basically the deployment job, right? So we want to pass this data over, and the only way we can pass data over is by using artifacts. Okay, so essentially what we are doing is we create this artifact called GitHub pages, and we specify that the path is to be the distribution folder or dist folder. Okay, so if you look at the diagram again, we have basically done step number 5, which is the publishing. And what step number 5 does is it pushes or uploads this artifact that we call GitHub pages to the artifacts of the current repository, right? So your repository has a bunch of artifacts, or you can have a bunch of artifacts. And in our case, we have one that's added, which is called GitHub Pages. Okay? So hopefully this process is clear for building and pushing an artifact. Okay? So at this point, is anyone confused or not sure about what we have just done with the build job? Anyone? Okay. Sorry? Yes. So artifacts can be available in different workflows and different jobs. It is basically some set of files that are stored by GitHub on your repository. That's it. So yes, basically that's it. Yeah. So the next part, which we have talked about, is the next step that we have for our CD pipeline, which is basically deploying. So what we want to do is, again, we define a new job. We specify it as deploy. And again, we specify it to run on Ubuntu, which is Linux. This time around, we actually add a new parameter or a new field, which we call needs. And this essentially creates the dependency that we see that we require, right? So again, we have a new workflow called CD. The event that triggers it is the push event. And what happens is that the first thing we do is we run a build. This is the build job. And the next job that runs is the deploy job. And because we specified needs as one of the parameters, since we specified needs as one of the parameters or one of the fields, deploy only runs when build finishes. Okay? So hopefully this should illustrate what I mentioned at the very beginning of this chapter, which essentially says that we have two different jobs that run, but we need one to be dependent on the other, right? Deploy needs to depend on whatever build has produced for it to actually deploy something. Okay? So now that we have created the bare bones of the deploy job, we can actually start specifying some parameters and some configurations for it. The first thing we will specify is something you will see called permissions. So essentially what happens every time you create a job or every time you create a workflow is that GitHub actually attaches something called the GitHub token. It is basically a way for your action to access the current repository. It can't access anything else, only the current repository, and it has some kind of permissions you have. It's very similar to like an API key that you might get. And so GitHub Pages uses this GitHub token to actually publish the page. So you need some permission to actually publish it up into GitHub Pages. And so in this case, we are not sure what permissions there are. So to be safe, we specify two new permissions, right? We specify the permission that the GitHub token for this particular workflow can write to pages, which is the GitHub Pages API. And it can also write to the ID token, which is ID token. Yeah. And basically what you see now is that the GitHub token that we have in this workflow now has write permissions to these two different effectively operations, right? There isn't any other magic that happens. There is no flashy UI. It just does it in the background. The other non-flashy thing that happens is the environments, right? So the environment in GitHub in this case basically tries to refer to some kind of deployment target. And essentially what this means is that you can kind of separate out your environment. You can have an environment for production. You can have an environment for staging, an environment for GitHub Pages in our instance. And all we want to do is we want to specify that the URL of this environment is page URL. So I will demonstrate what this looks like in a bit. But basically, you will see all we are doing is adding some new configuration to this job. And effectively what it does is it adds this new environment. Okay? And so now we have our very last step. Very simple, this job, right? All we need to really do is to deploy this artifact we created earlier. So remember earlier, if you look at this, we have this artifact living somewhere in our repository that we call GitHub Pages. This was created by the build step, or the build job, sorry. And what we want to do is we want to be able to deploy this artifact as part of the GitHub pages. We want the set of files in the distribution folder to appear as what we see on the GitHub pages. And so in this case, we'll use another action. We use deploy pages, and we specify the name of the artifact, which is whatever we named it just now, which is GitHub-pages, right? It's whatever is here, okay? And yeah, basically, this will take the artifact we created earlier, and it publishes it to GitHub pages. Relatively simple. The action does all of the heavy lifting for us. Yeah. And one other thing you should notice is that now we actually specify something called the ID. And the reason why we specify a step ID is because in the previous step here, we actually tried accessing that step. So if I call steps.deployment, I have access to the outputs of the step. And in this case, I'm interested in the page URL. So that's what I'm doing here, right? The curly braces and the $ are basically ways for GitHub Actions to read some kind of expression, which is whatever's inside, and it gives you the value of the expression. So it gives you, in this case, the page URL. Okay? Cool. So once again, I will hopefully make it simple for demonstration purposes. But basically, I will. Okay, you guys don't have. You guys can follow this if you want. But basically, you can edit the file on GitHub. Add this. So you can specify workflow dispatch : You don't have to specify anything. YAML knows that this is just the key. Doesn't really matter. And you commit the change. So again, just to quickly recap, all you have to do is under the cd.yaml file you created, put workflow dispatch here and run it. And so you commit the changes. And that's it. Okay, so now you should see that there is a workflow dispatch here. And now we can try running it, right? You can kind of ignore this because adding the file was equivalent to pushing to the branch, which caused it to trigger. But let's pretend like it didn't happen, and let's actually run it ourselves, right? So click again on the job here. You can click on run workflow here and click run. So again, if you refresh the page, you'll see that this runs, and you click into it, and you will see that there is basically the dependency graph I showed earlier, right? You have the build job that happens, and then the deploy job that is linked to it, right? So that specifies the sequential nature of our jobs. Okay? So if we open up build, you'll see that it's basically slowly running each of our steps that we specified in our job, right? It installs my dependency, it performs the build, and it uploads my production artifact. Okay? And once it runs finish, you'll see now that deploy actually appears. Because as I've said, we specified some form of dependency. So build finishes, then deploy can actually start running. Okay? And if you have been following, you actually notice that it fails. So this is expected again, where you have to actually go into your repository, go to your settings, go to the page called pages here, and underneath build and deployment, change it to GitHub Actions. Because otherwise, this doesn't treat the GitHub Actions as valid. It just fails, okay? So now I change it, let it refresh, and I'll go back to the action. And now I want to demonstrate another thing with GitHub Actions, which is you can rerun failed jobs, or you can rerun jobs. And so in this case, I will go back into the failed job. And if you select rerun jobs and rerun all jobs and confirm, it basically just reruns that same workflow that ran previously. So it goes through the build step again, and it goes through the deploy step again. Okay? So yeah. So we will wait for the build, and we will wait for the artifact to be published. So it's a bit faster now. And we should see deploy running. And this time around, hopefully, deploy will work, and we should see the page on GitHub or GitHub pages. Yeah, so in this case, you'll see here it succeeds. Good. If you go back to your actions, if you select the succeeding job, you actually see that there is now a URL at the bottom of deploy. So if you can click on it, did I click on it? Oh, I did. Yeah. So if you click on it, you will now see that for every single one of your own forks, you should see the application running on some domain. In my case, it's just nushackers.github.io. But if your name is Bob, it will be bob.github.io/CICD calculator, right? And if I start messing around with it, if I do 5 and I do 2, it will basically print 7. So basically now, what we have achieved here is essentially we've managed to be able to automatically deploy 2 GitHub pages using GitHub Actions, right? So if you guys are interested, you can try to make a push to this main branch, and you'll notice that it will also do another deploy. And that's essentially what we are trying to achieve, right? Where we have basically been able to set up this workflow here, where we have 2 different tasks that run. We have the task to run our unit test. We have our task to run our linting. And the final step is to actually merge and deploy it to main automatically. Sorry, deploy it to GitHub pages automatically when we have merged to main. Okay? So hopefully everyone has managed to follow through most of this, and you have basically been able to set up your very first GitHub Actions workflow. Okay? So now that we've kind of covered the basics of GitHub Actions, I don't know if anyone is like overly confused by it, but I think since we have like a bit of time, I'll just quickly cover some of the advanced use cases in case you are interested and looking to like abuse GitHub Actions. So there are kind of 4 new things we can do with GitHub Actions, right? The first thing we can do is we can create a poller. So I won't go through exactly what it does. I'll just explain the high level of what it is. Essentially, sometimes you want to run a workflow every day or every 2 hours or every single minute, something like that. So you can actually specify a new type of action or a new type of workflow that triggers on the schedule event. And all that does is it specifies some kind of duration, which is using something called cron, to run the workflow repeatedly, right? So in this case, we will run at 2 different times. And depending on the time that it runs, we can actually print different things, right? Again, I won't go through the specifics of this. This is just good to know. The next thing you might be interested in is if you want to actually be able to use GitHub APIs in your GitHub Actions. So the reason why you might do that is because I think I can demonstrate, which is something like this, where you might want to actually use GitHub Actions to publish PR comments directly in a pull request, right? You might want to demonstrate or show an error. You might want to show some success messages. You might want to do different things. And this is all achievable if we use an action called GitHub script, where basically we just call the GitHub API using some library that has been built in. And that effectively lets us access the GitHub API. Okay? I included a bunch of other things, including a way to like make a commit for you. So there is ways to like combine scheduled workflows with like GitHub scripts. I won't talk about it too much, but basically it's there if you want to read it. The second last thing is executing third-party scripts. So another thing you might be interested in doing normally is you might want to run a Python script in GitHub Actions. So this seems like a bit of a departure from what we have done previously, but maybe your Python script contains some kind of behavior that accesses some kind of API, and you want to do that in your GitHub Actions. Maybe it's not highly encouraged, but you can do it. So as I've said, you can treat your virtual runner or the virtual machine for your job as a operating system itself. So you can literally call Python on the script and you can execute the script itself. Okay? Yeah, again, I go through the clear details in the wiki, but for now, this is the high level of it. And the last one, which is, I think, somewhat pertinent to most people who are developing more complex apps, is something we call reusable workflows, where essentially the workflow can be generalized across different other workflows. So in this case, what I mean is, let's suppose I have 3 different folders, the web, the admin, and API, and all of them have the same set of instructions, right? We want to run the unit test and we want to run linting. If we create separate files for all of them, you will basically see this same file replicated 3 different times. Not very useful if I'm trying to make sure that I don't screw up one of the commands. So what I can do is I can create something called a reusable workflow. And effectively, the reusable workflow does what this original file does, but it takes in some parameters. It takes in like the working directory you need. And based on this reusable workflow, we can simplify each file to actually just call the workflow itself. Very simple. We can even actually combine them all to be the same workflow. So now I no longer need to manage 3 files. I just manage one singular file with 3 different jobs. And as I've said, because the jobs run in parallel, you don't really care which of them run at what time. They'll all eventually complete at the same at some point. Okay, cool. Yeah, the rest is extra stuff that you might not need, so I won't cover. But yeah, so basically, that's about it for the main thing for today. If you guys again don't have the link to the wiki, feel free to scan it.